two wedges A and B are employed to raise a load of 2000 Newton as shown in figure. Assuming coefficient of friction as 0.25 for all the surfaces and neglecting the weight of the wedges, determine the value of P for impending upward motion of the block C. So three blocks are there. A and B are acting as wedges, and C is the weight to be raised in the upward direction. In the upward direction. So that means these forces P should be applied as shown. Then only this wedges, that is A and B, blocks A and B will be moving towards inside or towards each other. Then, as an effect of this motion, the motion of these two, this block C will be moving in the upward direction. So this is the question. How can we solve this? How can we solve this? The same way as we did for the previous problem, we have to split these three blocks into separate blocks. Then draw the free body diagram by separating the reactions and forces acting on it. Draw the free body diagram correctly. Then apply sigma h equal to 0, sigma v equal to 0. Then you will get the answer. Here in this case, we can consider A and B as symmetrical about the centroid or the center of this block, this composite block. Okay, if you draw a line like this through the center, then this block and this block will be symmetrical, so that the action of forces will be same on both these one, even though the direction will be in the opposite direction. Okay, so let us split this into three blocks. So let this the first one, the block C, which is to be raised by applying a force of P. We need to find the value of P. So this is 2000 Newton. Then let us draw the free body diagram of the wedges first, so that we can easily get an idea of in what direction the frictional resistance will be acting. Okay, let this be block A, and let this be block B. Okay. Now, what are the forces acting on A? Let this be A. Okay, this be A and this be B. Then the first force is P in this direction on this one. Then there will be reaction from the floor. Let it be R F. Okay. If you want to distinguish between these two forces, here also will be a reaction. You can put it as RF left and RF right. Okay. But in this case, as this is a symmetrical say shape or section, you can assume that RF or the reaction on this point and this point, that is on A and B, will be same. Similarly, here also, that is from here there will be reaction onto this surface. Same value will be here also say generated because the angle is same, 30 degree, 30 degree. You can see this angle. Okay, the inclination of the surface is same. Therefore, the reaction will also be same. Okay. So here is the reaction from the floor. Then what about the reaction from this block onto the block A? It will be perpendicular to the surface like this. Perpendicular to the surface like this. Let this be RB. RB. Here also, in this block also, there will be same RB because of the symmetry. There will be same RB because of the symmetry. Clear? So let this be RB. Then what about the frictional resistance? As this force P will be pushing this block towards right, the frictional resistance on both the surfaces. This surface will be, the frictional resistance will be in this direction, uh, and here it will be in this direction. Is it not? So let this be F and this be FB. Hope it is clear. Okay. The same thing will be happening here also. There will be FB in this direction and FF in this direction. Okay. Then now we have the direction of frictional resistance on this block. Then here also there will be, this is RB, and there will be, here will be, on this surface there will be RB. Is it not? RB like this. RB. Here also another RB. Okay, from this one. this RB will also be acting onto this surface. Then how the frictional resistance will act? As this block is moving inside, the frictional resistance will be in this direction as shown here, FB, in this direction. Okay. Now here it will be in the opposite direction. That means it should be in this direction. This is the frictional resistance FB. And here also there will be another one, FB. Okay. So these are the forces acting on block C. Block C. The weight through the center of gravity, FB in this direction at this surface, FB another one at this surface, RB and RB. Okay. Now what we have to do is we have to resolve these forces into its components. Into its components. Okay. So these are the forces. Now let us resolve these inclined forces into horizontal and vertical components. This is in vertical direction. This is in horizontal direction. This is also horizontal direction. So we need to resolve this into split these two forces FB and RB into its components. So this will be having a component like this in the horizontal direction and the vertical direction like this. Okay, and this will be 30 degree. This will be 30 degree. Then what about this one RB? RB will also have components like this horizontal component and a vertical component. Horizontal component and a vertical component. And this angle will be 30 degree. If you look at the geometry itself, you can see that this will be 30 degree. Okay, so this component will be the cos component and this component will be the sine component. Here, this component will be cos and this will be sine. So this is so this component will be FB. FB is, and also it is impending upward. This say mention that impending upward. Okay, when you apply a force of P from left and right on these two blocks A and B, then this block will be moving up. Okay, and the motion is impending. That means this FB is a limiting friction. Limiting friction. Okay, so limiting friction, we know the equation F is equal to mu into Rn, the normal reaction at that point. So here mu is 0.25 for all the surfaces. 0.25 is given. Therefore, this component will be, I'll write this component first, 0.25 into the resistance, the reaction at this surface is RB. Is it not? RB, and this component will be sine 30. 0.25 RB sine 30 is this component. 0.25 RB sine 30 is this component. Okay. Then this component will be 0.25 RB cos 30. Cos 30. Okay. And this component will be RB cos 30. Because this is the right angle triangle, this is the right angle, this is the right angle, this is 30 degree angle, therefore RB cos 30. This is the adjacent side. This will be RB sin 30. This will be RB sin 30. Okay. So these are the forces and its components for the block A or wedge A or the wedge on the left side. The same force components will be coming on this one also, but the direction will be different like this. That's all. That's the only difference. Okay. Then P also will be here. Okay. Now we can draw the. So we need not consider this one. We will draw the free body diagram with the forces solved into its components here. There we don't have space to write. That's why I'm drawing it here. Okay. So at this point, there will be one component that is a component of this one. So it will be like this. Okay, component of this force RB. So this is RB, and this will be 30 degree. The angle will be 30 degree. Okay. Yeah. This angle is 30 degree. Therefore, this is 30 degree. Therefore, this will be RB cos 30. Why it is RB? Because from this surface, the reaction will be same on to this, and the same will be here on the to the block from the block A to C. Same reaction will be there. So RB cos 30, this will be RB sin 30, will be RB sin 30. Similarly here also, this is the force RB and its components will be like this. This is 30 degree. So this will be RB cos 30 and this is RB sin 30. Then the frictional resistances will be it is in this direction here like this towards this one. Therefore, this will be the components. So and this angle will be 30 degree. This will be 0.25 RB cos 30 and this will be 0.25 RB sin 30. Similarly here also there will be two components like this, and this is the frictional resistance. This will be 30 degree. Therefore, this will be 0.25 RB cos 30 and this will be 0.25 RB sin 30. Then which is the force remaining? 2000. This is the free body diagram for the block. Okay. Now what we can do is we can apply equilibrium conditions for block C as well as block A. So let us consider block C. Let us consider block C. Then apply sigma V equal to 0. What will be sigma V equal to 0? These two forces are acting in the upward direction. These three forces are acting in the downward direction. So it will be RB cos 30. There are two forces acting in the upward direction. Therefore, I write it individually. RB cos 30 plus RB cos 30. Then minus which one? This 0.25 R by RB sin 30 is acting downwards. This one. Okay. Minus 0.25 RB sin 30. Again on this side minus 0.25 RB sin 30 and minus 2000 equal to. Is it okay? RB cos 30 acting upwards taken as positive. RB cos 30 acting upwards taken as positive. Then 0.25 R by sin 30. This one acting downwards. This force. Then the other one here it is acting downwards. Then again this one minus 2000 equal to 0. Okay. Yeah. So here only RB is the unknown. Only RB is the unknown. Then you can get RB, value of RB from here, and the value will be 1349.53. This will be RB. 1349.53 is the value of RB. Okay. Then now consider block A, that is the left wedge. So let us consider block C, block A. Now consider sigma V is equal to 0. What are the forces? Which are the forces acting in the vertical direction? RF, is it not? RF, that is the reaction from the floor. RF, it is acting in the vertical upward direction, taken as positive. Then this one taken as positive, 0.25 RB sin 30 plus 0.25 RB sin 30. Then another force acting in the vertical direction is RB cos 30. RB cos 30, this one, minus RB cos 30. No other forces are acting in the vertical direction, correct? Equal to 0. Three forces are acting in the vertical direction. Therefore, RF plus 0.25 RB sin 30 minus RB cos 30. This RB is put as reaction from the block. Okay, reaction from the block, and it is denoted by RB. Okay, and here also we have the value of RB. So when you put the value of RB, you will get equal to RF equal to approximately 1000 Newton. 1000 Newton. RF is equal to 1000 Newton because RB, the value we have already here. Substitute here. The only unknown is RF. Okay, 1000 Newton. Hmm? Now sigma H is equal to 0. Using that, you can find out P. So, which are the forces acting in the horizontal direction? P. It is taken as positive because it is towards right. P. Then minus 0.25 RB cos 30 minus RB sin 30 minus, here is one force FF, is it not? Friction at the floor and the wedge A. Wedge A minus FF is equal to 0.25 into RF. RF is 1000 is the frictional resistance. It should be equal to 0. Now we know the value of RB. RB is 1349.53. Then you can substitute the values. Then you will get P is equal to 1216.95. 1216.95